In this video, we're going to answer every question from the IGCSE Computer Science Specimen Paper for 2023, Paper 2. Let's get started. Question 1 says, 4 pseudocode descriptions and 5 pseudocode statements are shown. Draw a line to link each pseudocode description to the most appropriate pseudocode statement. Some pseudocode statements will not be used. So on the left, we've got some descriptions. On the right, we've got some statements. Let's read through each description. The first one says a loop that will always iterate at least once. So this will link to one of the loops. We have a for loop, a while loop, and a repeat until. In this case, it's going to be the repeat until, since this will always loop at least once, given the condition is at the end. So let's link those two. The next description is a conditional statement to deal with many possible outcomes. We have 2 different conditional statements. We've got the if statement and the case of. In this case, it'll link to the case of, as it mentions that we're dealing with many possible outcomes. So let's link those two. The next one says a loop that will always iterate a set number of times. Another word for this would be a counter-controlled loop, which in this case would link to the for loop. So let's link those two. Lastly, we have a conditional statement with different outcomes for true and false. We've already linked to a case statement, so this must correlate to the if statement. So let's link those two. There we have question 1. Let's move on. Question B says, using a single loop, write an algorithm in pseudocode to output 50 names that have been stored in the array name. Whenever you solve pseudocode questions, you never want to go directly into writing pseudocode unless you're very confident as to what the answer is. Instead, we want to write down the steps that we need to take in order to write our pseudocode algorithm. So I'd recommend doing this on the side in pencil, where we're going to write down what steps we need to take to complete this pseudocode algorithm. The first thing we know is that we've been given an array called name, and this array stores 50 names. So to read all the elements in this array, we need to loop through each element, meaning we're going to need a loop that runs 50 times. So that's going to be our first point. The array contains names, so inside the loop, we want to output the name that we're at. That's the only thing that needs outputting, so now we can take this and expand a bit on it. So for example, we can choose the specific loop that we're using. With programming, you can really use whatever loop you want, but I think in this case it would be easiest to use a for loop since we know exactly how many times we're going to loop. So let's add a bit more detail to the step. Then when we output the name, we need to understand how we're selecting the name. The name is coming from this array, and we'll be selecting it using the index given by the for loop. So the code would look something like this: name at the position of index. Now that we've got our outline, let's write the pseudocode. We'll start off by declaring a for loop. For loops always have a counter variable, let's call it index in this case. The counter variable needs to start somewhere and needs to end somewhere. Arrays usually start at index 0, so we can set the index to start at index 0. The array is going to loop from 0 up to 50, since we're outputting 50 names. So we'll write to 50. That's the first point complete, so we'll mark that as complete. Now we need to output the name inside the loop. The keyword to output something in pseudocode is simply output, and we'll use the code that we wrote here, name at position index. That's the step complete, so we can mark it as complete. The last thing to remember is with pseudocode formatting, we always need to end the for loops. And we can do that by writing next index. And there we go, that is this question complete for 3 marks. Question 2 says describe the purpose of validation and verification checks during data entry. Include an example for each. This is a purely theoretical question, which essentially just requires memorization of these topics. The main thing to be aware of is that this question is worth 4 marks. Which means we need to write 2 points for validation check and 2 points for verification. You can see which points we need to write by looking at the question. First, we need to describe the purpose, then we need to include an example. So let's start off with validation. The purpose of validation is to test if data entered is reasonable, in other words, if it fits within any specific values, or if it follows a specific format. So for the second mark, we can write an example as a format check for dates that are entered in the format day, month, and year. You can give any validation check as an example here. For example, the range check, length check, presence check, or format check. And you should get the mark. Next, we'll look at verification. Verification checks on data input tests if data entered is accurate. In other words, if it is data that was intended to be input. The example, we could say double entry, which requires data to be entered twice and compares both entries, making sure that they are the same. This completes question 2. Let's move on. Question 3 says tick one box to show the named section of a program that performs a specific task. A file is a unit of storage which stores data. A parameter is a value or a variable that gets passed into a function. A process is a program which is loaded into the computer's memory and carries out specific tasks, which means that the answer must be function, which is used to show the name section of a program and performs a specific task. Let's move on. Question 4 says a satellite navigation system is an example of a computer system that is made up of subsystems. Part of a satellite navigation system allows the user to enter details for a new destination, or select a previously saved destination, and displays directions in the form of a visual map or as a list. Draw a structure diagram for this part of the satellite navigation system. So whenever we are asked to draw structure diagrams, we usually want to break up the system into 3 different parts: inputs, process, and outputs. We need to identify the inputs of the system, identify which processes are occurring, and identify the outputs. This breakdown is a bit too simple for complex programs, but for programs that are short and simple, it works quite well. So let's go ahead and start with input and see what inputs we're taking in with this system. The first point says that it allows the user to enter details for a new destination, or select previously saved destinations. So let's write these 2 points under the input. Let's go over to process. Reading through the specifications, they haven't outlined any particular processes that are occurring, in which case we're not going to try and guess any processes that happen. When drawing the structure diagrams, we always want to stick very closely to the specifications they outline, so we won't write anything for the process. Let's see if there's any outputs. In the specifications, they say it displays directions in the form of a visual map or as a list. So let's write these 2 points down. Now that we've done all the initial work, we can go into drawing the structure diagram. Again, you never want to go directly into drawing the structure diagram, unless you're completely confident you know what the answer is going to be. It's always a lot better to write down the input process outputs of the system, just so that you don't miss anything and don't miss out on any marks. The top level of your structure diagram should always be the name of the system. In this case, it is Satellite Navigation System. Then we can break it down into its subprocesses, the input process output. Let's start with input, since input occurs first in the IPO model. We'll connect the top layer to the second layer using a straight line. Try to be a bit more straight than this. Now would be a good time to use a ruler. Now with input destination, we can decompose it into 2 more layers. One which selects the new destination and one which selects the previous destination. Also, as a side note, you shouldn't really use color. I'm just using it here to make it clear as to what the different parts mean. And also it looks a bit better. Alright, let's move on. There's no process as we figured out, so let's draw the outputs. Within output directions, we can decompose it into the 2 different parts, outputting the directions as a map and as a list. And there we have the completed structure diagram. Let's move on to the next question. Question 5 says, an algorithm has been written in pseudocode to input some numbers. It only outputs any numbers that are greater than or equal to 100. The number 999 is not output and stops the algorithm. Questionnaire says, identify the 4 errors in the pseudocode and suggest corrections. To answer this question, we are taking the pseudocode and we're comparing it against the original paragraph. The original paragraph is the correct version. The pseudocode has some errors which don't quite align with the specifications in the paragraph. The quickest way to answer this type of question is to take the specifications and write them in point form, to make it easier to understand what this program is asking us to do. So let's read through the specifications. An algorithm has been written in pseudocode to input some numbers. It only outputs any numbers that are greater than or equal to 100. So let's write down the first point, in that it only outputs numbers that are greater than or equal to 100. So we can write down that numbers must be greater than or equal to 100. The next line says the number 999 is not output and stops the algorithm. So this means that when we enter 999, this will stop the algorithm, and it shouldn't be output. Alright, now we have our specification list, and we understand what the program is trying to accomplish. The program is going to take in a list of numbers. The while loop will end when we enter the number 999, and will output any numbers that are entered greater than or equal to 100. So, when we're looking for errors, there are 2 types of errors that we're looking for. The first type is called syntax errors, and the second type is called logic errors. Syntax errors are errors that occur when the code violates the syntax rules of the programming language. So, for example, if we misspelt anything, or if we forgot to close a while loop, or if we used an incorrect character, those would count as syntax errors. Logic errors is a type of error that occurs when the code is run without any errors, but it produces incorrect results. This would happen when the code that we wrote is not written correctly. So let's start off by looking for any syntax errors. These are quite easy to find. since they violate the rules of the syntax of pseudocode. So the first syntax we can see is in this line, numbers. The numbers variable doesn't exist. You can see all the other times we've been using the number variable, so that is a syntax error we'll write as the first error. On the first line, we'll write the error. We can just write out the entire line. Then for the correction, we'll write the correct version. We'll see if we can find any more syntax errors. If you scan through the code, it doesn't seem like there are any other syntax errors, and this code follows all the syntax rules of pseudocode. So we now want to look for any logical errors. For this, we can refer to our points. The first point says that we only want to output any numbers that are greater than or equal to 100. If we look at our code, inside the while loop, we're checking if the number is greater than 100. And only if it's greater than 100, we output the number. So there is the second error. This greater than sign needs to be greater than or equal to. Let's write in this line as the second error, and we'll write the correct version. We'll then check the second point to make sure that 999 stops the program. In this case, we've got a while loop, which checks if the number is not equal to 999, then it'll end the while loop. However, we're only inputting a number once. Inside the while loop, we don't actually change number. So in this case, we're going to run into an infinite loop, since number is never being changed inside the while loop. To fix this, we'll add input number after this if statement. So in this case, we can't write out what the line of the error is, since there is no line. Instead, we need to describe what the error is, so we can say that input number is missing inside the loop. For the correction, we can write insert input number after the end if. The other part of the specification is that the number 999 is not output. However, after the while loop, we output the number. This means that when they input the number 999, the while loop is going to end, but then we output 999. So this line is incorrect, and it needs to be removed. So let's write this line as the fourth error. We can just write in output number, and the correction is to remove this line. And that is this question for 4 marks. Question B says to write a pseudocode statement to change the corrected algorithm to output all numbers between 100 and 200 inclusive. You do not need to write the whole algorithm. So we know what the purpose of this algorithm is based on the previous slide with our different points, saying that numbers greater than or equal to 100 are output and 999 stops the program. In this case, they want to change the program such that we want to output all numbers between 100 and 200 inclusive. So the first point is going to change to this. We want to output all numbers between 100 and 200. The code that took care of this was this if statement, which checked if number is greater than or equal to 100 if we look at the corrected algorithm. This means that we're going to change this if statement in our new algorithm. In the if statement, we want to check if the number lies between 100 and 200 inclusive. Since we don't need to rewrite the whole algorithm, we can simply write the updated if statement in our answer. So let's start with if. Then we'll check if the number is greater than or equal to 100. We're using greater than or equal to make sure that it's inclusive, as given by the specifications. We'll then use the AND operator and write the condition number less than or equal to 200. Again, using less than or equal to make sure we're including 200. This condition will only return true if number is between 100 and 200. So there is the answer for question B, and let's move on. Question 6 says, consider this logic expression, draw a logic circuit for this logic expression. Each logic gate must have a maximum of 2 inputs. Do not simplify the logic expression. Alright, let's go through the process of drawing a logic circuit given this logic expression. We'll rewrite the logic expression over here so that we can simplify it. And to do so, we'll follow this process. First, we'll find the gate with the most brackets around it. Then we'll draw the logic gates, drawing any NOT gates first, and we'll label the gates. Then we'll rewrite the logic expression with the label. So to start off, we'll find the gate with the most brackets. We have 3 candidates. First is the AND gate, then we've got this AND gate, and we also have this NOT gate. Whenever we have multiple candidates, we'll just go from left to right. So let's go ahead and draw this AND gate. The inputs for the AND gate is A and B. So we'll draw the AND gate around about here, and we'll connect it up to the inputs A and B. Then we want to label the gates. Let's give it a label of L. You can make the labels whatever you want. I just like to start in the middle of the alphabet, since it's easier to separate it from the beginning and the end. Then we want to rewrite the expression with the label included. So what that means is we're going to rewrite this expression, replacing A and B with L. We'll also rewrite the other parts that we haven't drawn yet, so OR, B, and not C. Now we're going to repeat this entire process for this new logic expression. First off, find the gate with the most brackets. In this case, we have two candidates. We have the AND gates and the NOT gates. The second step says to draw the gates, drawing any NOT gates first. So we're going to draw this NOT gate. The input for the NOT gate is C, so we're going to draw the NOT gate around here, and we'll connect it up to C. Then we'll give it a label. Let's label it M, and we'll rewrite the entire expression, replacing NOT C with M. So the expression should look like this. Let's repeat the process again, and the gate with the most brackets around it is now this AND gate. So let's go ahead and draw that AND gate. The inputs are B and M, so we'll draw the AND gate around here, and we'll connect it up to B and C. Whenever you have this split connection, it's always good to draw a dot, just to indicate that this is a split and the origin is coming from B. Next, we can give this gate a label. Let's label it N, and rewrite the entire expression again, replacing B and M with N. Let's repeat the process one last time. We'll find the gate with the most brackets. In this case, there's only one gate, which is the OR gate. The inputs for the OR gate is L and N, so we'll draw the OR gate around about here to connect to L and N. Then we can connect up L and N, and we'll give this a label. Let's label it P, and again, rewrite the logic expression, replacing L or N with P. The logic expression says that X is equal to the output of P, so we'll connect the output of P to X. And there we have the completed logic circuits, and that is this question complete. Question B says, complete the truth table from the given logic expression. The first thing to do when we get a truth table question is to count the number of logic gates in the logic expression. Then we'll split up the working space into 4 equal columns. The reason for this is that to work out the truth table, each gate will be using a column. Let's rewrite the logic expression again on the right-hand side. The process to complete a truth table given an expression is very similar to the process of drawing a logic circuit from an expression. First step is to find the gate with the most brackets around it. Then we'll label that gate and evaluate the gates, evaluating any NOT gates first. Then we'll rewrite the expression with that label. So since this expression is the same as the one we used to draw the logic circuit, we'll evaluate the AND gate first. We want to label this gate, so let's label it the same as we did with the circuit. We'll label it L. We then want to write L in the first available column in the truth table. To evaluate a gate, we need to apply the AND gate rule to every row of the inputs of L. In this case, the inputs are A and B. A good way to keep track of what inputs you're working with at the moment is to use pencil and underline the inputs. So for each row of A and B, we'll apply the AND gate rule and write the output in the L column. The rule for the AND gate says that the output is going to be 1 if both inputs are 1. Otherwise, the output will be 0. So let's evaluate each row, starting at row 1, where the input for A is 0 and the input for B is 0. This means that the output is going to be a 0, since it doesn't follow the rule. The second row is the same as the first, so the output will be 0. The third row says that the input A is 0 and the input B is 1, which again doesn't follow the rule, so the output will be 0. And the fourth row is the same, with the input 0 and 1, giving us an output of 0. The fifth row, input A is 1, but input B is 0, so again it doesn't follow the rule, and the sixth row is the same. The seventh row, input A is 1 and input B is 1, which does follow the rule, so the output is going to be 1. And the eighth column is the same, so the output is going to be 1. And there is this column complete. The last step of the process is to rewrite the expression with the label. So let's rewrite this expression, replacing A and B with L. Following the same order as our logic circuit, we'll evaluate the NOT gates. We'll first give it a label of M, and we'll write M in the next available column. The rule for the NOT gate is to inverse the input, so we're going to apply the NOT gate rule to input C. Let's underline input C, so that we can keep track of which column we're working with. For the first row, C is 0, so inverting that input, we get 1. For the second row, C is 1, so inverting that, we get 0. For row 3, C is 0, so we'll invert that and get 1. And you can see it follows a pattern going 0, 1, 0, 1, 0, 1. So our pattern will be 1, 0, 1, 0, 1, 0. Let's again rewrite the expression, replacing not C with M. The next gate to evaluate is this AND gate between B and M, which will give a label of N, and we'll write N in the next available column. We already know the rule for the AND gate, which is that the output will be 1 if both inputs are 1, otherwise the output will be 0, and the input is B and M. So we'll underline B and M. Let's apply the AND gate rule to each of these columns. For the first row, we have B as 0 and M as 1, which doesn't follow the rule, so the output is going to be 0. The second row, we have b is 0 and m is 0, so the output will be 0. The third row, we have b is 1 and m is 1, which does follow the rule, so the output will be 1. The fourth row, we have b is 1 and m is 0, so the output is going to be 0. For the fifth and sixth row, b is 0 for both inputs. So we know that the output is going to be 0 regardless of what m is. For row 7, b is 1 and m is 1, so the output is 1. And row 8, b is 1 and m is 0, so the output will be 0. Let's again rewrite this expression with the label n. The final gate to evaluate is the OR gate. We'll give it a label of p, and we'll write p in the last available column. The rule for the OR gate is that the output is 1 if either input is 1, otherwise the output is 0. The inputs for the OR gate is L or N, so let's underline those two columns, and we'll apply the OR gate to each row. Starting with row 1, we have L is 0 and N is 0, so this doesn't follow the rule, meaning the output is going to be 0. For the second row, we have the same case, 0 and 0, which gives us 0. For the third row, L is 0, but N is 1, which does follow the case since at least one of the inputs is 1. So the output will be 1. For the fourth row, we have 0 and 0, which gives 0. The fifth row is the same, and the sixth row is also the same. For the seventh row, both inputs are 1, so the output is 1. And the eighth row, at least one input is 1, so the output will be 1. Let's rewrite the logic expression one last time. Now we can see that x is equal to p, so we're going to copy the entire column for p into the output column x. And there is this question completed. Let's move on. Question 7 says that this flowchart represents an algorithm. The array name used in the flowchart contains the following data. Complete the trace table using the data given in the array. To complete a trace table, we don't necessarily need to understand what the algorithm is doing. However, it does help us understand what the algorithm is doing. To start off, they've entered the data from the array into the first row of the trace table. So our input must begin on the next row. When completing a trace table, whenever we enter a new loop, we go on to the next line. You can see in this flowchart we have two loops. One outer loop where the condition is at the end, and one inner loop where the condition is inside of the outer loop. We start off by assigning this variable flag to 0 and count to 1. So in our trace table, we'll find the flag column and we'll set that to 0, and the count column and set that to 1. Then we enter our inner loop and we'll check is the name at the position of count greater than the name at position of count plus 1. Count is equal to 1, so the name at the position of count is Jamal. The name at position of count plus 1 is Amir. This decision block compares strings, checking if the first string is greater than the second string. When comparing strings, we always start with the first character, checking if the first character is greater than the other character. Character comparisons work by comparing the ASCII values, in other words, the alphabetical values of these characters. So J is greater than A, since its ASCII value is larger. In other words, it lies later in the alphabet than A. So this if statement is true, meaning we'll follow the yes line. We then get to a process block, which sets the variable temp to be name at position count. We have a temp column over here, so we'll set that to Jamal. The next process block says name at position count is set to name at position count plus 1. So we'll set name at position of 1 to Amir. The next process block says name at position of count plus 1 is set to temp. So we'll update name at position 2 with the value in temp, which is Jamal. Then we update the flag to be 1. So we'll go to the flag column and set that to be 1. The next process block says to set count to count plus 1. So we'll increment count by 1 in the count column, setting it to 2. This decision block says, is the count equal to 4? Currently the count is 2, so it is not equal to 4, meaning we'll follow the no line, and that loops back to the beginning, checking the current values of name at position count and name at position count plus 1. These values have now changed, since the variable count has changed. Name at the position of 2 is equal to Jamal. Name at the position of count plus 1, which is 3, is equal to Eve. We want to check if Jamal is greater than Eve. In other words, comparing the first value, checking if it lies later in the alphabet than Eve, which in this case it does. So we'll follow the yes line again, which sets temp to be name at position count. So again, we'll set temp to be Jamal. Then we'll update name at position count to name at position count plus 1. So name at position 2 is going to be set to Eve. Then we have name at position count plus 1, which will be updated to temp. So name at position 3 we'll set to Jamal. Finally, we'll set the flag to 1. The next process block increments count to count plus 1, so we'll increment count to 3, and we'll check if count is equal to 4. Count is only equal to 3, so again we'll loop back to the beginning. Again, we're checking this decision block, which is comparing name at position count to name at position count plus 1. These values will get updated, again, since count has changed. So name at the position of 3 is Jamal, and name at position of count plus 1, which is 4, is Tara. We can now evaluate this decision block, checking if Jamal is greater than Tara. This decision block is false, since J is not greater than T. So we'll follow the no line. We'll increment count to count plus 1, so we'll increment that to 4, and we'll check if count is equal to 4. In this case, it is, so we'll follow the yes line. This decision block checks if flag is equal to 0, flag is currently 1, so we'll follow the no line. This loops all the way back to the beginning, where we set flag to 0 and set count to 1. Let's go to the flag column, and we don't want to update flag on this line, since this is not part of the same loop. When we updated count, that was part of the previous loop, so we need to update count on the new line. Then when we update count, we can set count to 1 on the same line since this is the current loop. Now we can go into the inner loop, which checks if the name at position count is greater than name position count plus 1. So these values will be updated. First, name at position count, which is 1 at the moment, is Amir. Name at position count plus 1, so name at position 2 is equal to Eve. We'll check if Amir is greater than Eve, but E lies later in the alphabet than A, so we'll follow the no line. We'll increment count to count plus 1, so count becomes 2, and we'll check if count is 4, which it isn't, so we'll loop back. And again, we'll perform this decision on the next values of name at position count. So count is now 2, name at position of 2 is equal to Eve, and name at position of 2 plus 1, so 3, is equal to Jamal. We'll check if E is greater than J, which is false, so again follow the no line, and increment count to count plus 1. Is count equal to 4? It is not, so we'll follow the no line, and again loop back. Count is now 3, so name at the position of 3 is equal to Jamal, and name at position of 3 plus 1, so 4, is equal to Tara. Jamal is not greater than Tara, so we'll follow the no line once again, incrementing count to count plus 1 on the next line. We'll check if count is equal to 4, in this case it is, and we'll check if the flag is equal to 0. The latest value of flag is 0, so we'll follow the yes line, which tells us to stop, and there is the completed trace table. The next question asks us to describe what the algorithm represented by the flowchart is doing. To complete this question, we can have a look at the trace table and understand what is happening to this array. You may recognize this section of the algorithm as the swapping algorithm. This takes two variables or two elements of the array and swaps them. Algorithms which require swapping of elements of an array is usually a type of sorting algorithm. If we look at the initial array, we can see that the data is not sorted in alphabetical order. However, if we take a look at the last values of each element in the array, we can see that the data is sorted. First, we have a name starting with A, then E, then J, then T. So this is definitely some type of sorting algorithm. To determine what sorting algorithm it is, we need to look at the nature of the sorting. On the first iteration of our outer for loop, the first value that we checked was Jamal against Amir. Then if we follow the position of Jamal on each iteration of the inner for loop, you can see that Jamal gets bubbled to the right position in the array. The algorithm which bubbles the largest value to the end of the array is known as a bubble sort. Whenever we perform a swap, the flag is set to 1, and the program only ends if the flag is equal to 0. So we can be sure that this is a bubble sort algorithm. Let's go ahead and write this into the description. Remember, it's for 2 marks, so we need to give 2 points. First off, we can say that it is a bubble sort algorithm. Then we can say that it sorts names in alphabetical order, and that will give us 2 marks completing this question. Question 8 says, a programmer has written an algorithm to check that prices are less than $10. These values are used as test data. 10, 9.99, and 10. State why each value was chosen as test data. This is again another purely theoretical question, which just requires memorization of the types of test data. When we are testing programs, we usually choose a set of test data comprising of normal test data, boundary test data, and abnormal test data. Normal test data is data that should pass the validation check with no errors. Boundary test data is data which is at the limit of our validation check, and will either pass or not pass based on the type of boundary test data. Abnormal test data is data that should always fail, and the program should reject this type of data. So now that we understand the types of test data, we can go through each different type of data and say why it was chosen. This algorithm has a check which makes sure that prices are less than $10. 10 lies on that boundary, so we can say that this is boundary test data, which should be rejected. $9.99 is also on the boundary, but in this case it should be accepted, so we'll say that it is boundary test data, which should be accepted. Finally, we have the word 10, which is not a number, so this would be abnormal test data, which should be rejected. And there is this question completed. Question 9 says, explain why a program might need to store data in a file. This is also a purely theoretical question, where we need to give 3 points and just requires memorization of the topic. When we're writing a program, we store data in variables, constants, and other data structures. Data that is stored in one of these is known as dynamic data, since when the program stops running, it gets deleted. In other words, it is temporary. Oftentimes, when we're running a program, we might want to store data that we've used in the program into a file to be stored on our drive. This would be called permanent data, and this is where files are used. The reasons for storing data in files are as follows. First, data is stored permanently even if the program stops or if the computer is switched off. Once the data is in a file, it can be transported to other devices or systems. And finally, data can be used by other programs, or it could even be reused when the program starts again. The only thing with this question is to make sure you give 3 points since the question's for 3 marks, but that is this question complete. Question 10 says, a function is declared using pseudocode. Tick one box which accurately describes the use of the variable inches. The inches variable in this case is passed to the function as a parameter. Any variables that appear between the brackets of the function header are always known as parameters. So the correct answer here is parameter. Question 11 says a database table 2018 MOV is used to keep a record of movie details. State the number of records in the database table. The number of records just means the number of rows. So all we need to do is count the number of rows, and that gives us 20. Question BI says give the name of the field that would be used for the primary key. The primary key is a field in our database table which contains unique values. We can look through each of these fields and determine whether the values could be repeated or not. For title, we could definitely have 2 titles that are the same. For genre, you can already see that there are 2 values that are repeated. For genre 2, we have the same issue. For Blu-ray, we're storing booleans, so these are always going to be repeated. DVD can also be repeated, and streaming can also be repeated. So the only one that can't be repeated is cat number, meaning the answer is going to be cat number. Next question says state the reason for choosing this field for the primary key. The reason is that cat number is a unique identifier for each record in our database table. We can say that it uniquely identifies each record. And there is this question completes. Question C says to complete the table to identify the most appropriate data type for each field based on the data shown in the database table 2018 MOV. There are a couple of data types we need to know when it comes to database tables. The way we work it out is by going to the field name and looking at the data, determining what is the best data type used to store that data. So for cat number, since this contains numbers and letters, the best data type would be the text data type. Then for title, title contains letters and numbers as well, so we'll also put text. Genre 1 contains a number of different types of genres, which are listed as text, so we'll write text. And for the field streaming, streaming contains either yes or no, which is only 2 different values, so we can simply write boolean. Since they do not use the words true or false, you could also write text here if you wanted to, but boolean is more appropriate. Next question says complete the structured query language to return the category number and title for all comedy movies. They've already given us a large portion of the SQL. In this case, we're writing a select statement. Whenever we write a select statement, we always need a from. So we would select the fields, then we'd say where the data is coming from. In this case, it comes from the 2018 MOV table, so we need to put the keyword from. We then have a where clause, which filters the data, and the where clause compares genre 1 against something. In the question, they say that we want to return the category number and title for all comedy movies. In the Genre 1 field, you can see that we have comedy listed as some of the entries. So we want to select records where the Genre 1 is equal to comedy. Make sure to put quotation marks around comedy since comedy is a text. And that is this question completes. Moving on to question 12, the variables x, y, and z are used to store data in a program. X stores a string, y stores a position in the string, and z stores the number of characters in the string. Write pseudocode statements to declare the variables x, y, and z. When we declare variables, we need two bits of information. We first need the variable name, then we need the data type of the variable. So for the first variable, we have x, so let's start off by saying declare x. The data type for this variable is a string, as given in this question. So we'll write :string. The next variable is variable y, so we'll write declare y. In this case, y stores a position in the string, so for example, 2. This means it's going to be an integer. So let's write integer. The last variable we have is z, so we'll write declare z. Z stores the number of characters in the string, which again means that it's going to be an integer. And there is this question completes. Let's move on. The next question says the function length x finds the length of the string x. The function substring xyz finds the substring of x starting at position y and z characters long. The first character in x is in position 1. Write pseudocode statements to store the string programming is fun in x, find the length of the string and output it, extract the word fun from the string and output it. The specifications for this program are quite simple. They already give us a step-by-step of what exactly we need to do. However, if you get a tougher question in the exam, I'd recommend writing the steps down by decomposing the question. However, in this case, we can just solve each question step by step. So first, store the string programming is fun in x. If we're updating a variable, we'll first write the variable, then we'll use the left arrow for assignments, and we'll write the string programming is fun. That's the first point solved, so let's take it as complete. The second point says to find the length of the string and output it. They tell us here that the function length finds the length of the string x. So we can simply use the output keyword to output. Then we'll call this function length, and as the parameter, we'll put x. And that is the second point complete, so we'll take that as complete. The last point says to extract the word fun from the string and output it. They've given us a function substring, which takes in parameters x, y, and z, and gets the substring. X is going to be the input string, y is the starting position, and z is the number of characters in our substring we want to select. The string we've been given is programming is fun, where we want to extract the last portion of it. So we need to determine what the starting position is of this string and the length of the string that we can assign to y and z. We'll start with the position, which we're going to assign to variable y. To determine the starting position, we'll count starting at 1, going up until we reach f. The reason we start at 1 is because they tell us that the first character in x is position 1. So starting at 1, we'll count up, and we'll see that f is at position 16. So we'll assign 16 to y. Then we need z, which is going to be the number of characters we want to extract. In this case, fun is 3 characters, so we'll create a variable z, and we'll assign it to 3. Finally, we want to use the substring function and output it. So let's write the output keyword and call the substring function. Inside the brackets as the parameters, we can put x, y, and z. And there is this question completes. Question 13 is the long question, which I've already made a video for, going through the Python solution. So if you'd like to watch that, it'll be linked in the description. Otherwise, if you're writing your exam soon, good luck, and I hope this video has been useful in going through some of the concepts of the new syllabus.